is going to impact. So we talk about 3D printing as additive manufacturing. We are not using the word 3D printing because the moment I start using the word 3D printing, it's like everybody is focused on prototyping. When we start talking about manufacturing, now that's a different one. So manufacturing is then you start correlating these machines with technologies, with CNCs, with milling and all those things. And that is exactly where 3D printing or additive manufacturing plays an important role. So let me just take you through. There are certain challenges. And what are those challenges? Some of them I have jotted down. So one is increasing range. Because this is not just for EV, but it is for all automotive range. Because you need to have components or you need to have vehicles which will give you more mileage, which will give you more increase in range. And how this can be addressed? Either you make a component lightweight or you consolidate your components. So you got might be 3-4 components which are joined using nut and bolts. Remove all those nut and bolts, you are going to reduce your weight. The moment you reduce your weight, you are going to increase your mileage or your range, whatever that may be. Cost reduction. Again, today morning we have heard cost reduction is one of the key points everybody is talking about. There is always a pressure that the cost of so-and-so item or the vehicle has to be reduced. So cost reduction is something which is very important. How do you reduce cost? You can reduce cost by lowering the manufacturing cost because that is something which everybody is paying from the pocket. Speed to market. Now this is something all automotive people are doing. You are launching new vehicles, new variants regularly, and how you will stay ahead of your competition is with this. You launch more and more variants than your competition. So that is speed to market is something which is a challenge. And lastly, customization. Now customization is not much in India, but very soon it will come to India. People are going to talk about customization. I am going to go to a dealer and I am going to say I need a customized vehicle with my name on it or my fender or my wife's name on it. It could be anything. But this is going to come. Trust me, down the line you will see this also. People are going to go and companies will offer it at a premium, but they will offer it. So customization is something which everybody is going to talk about. So let me just draw EV electric where they have consolidated the parts. So it's lightweight part consolidation. So here you can see they consolidated number of parts together so that they could get the benefit out of it. So there was a design freedom. Now with additive manufacturing, you get a whole lot of design freedom. You are not going to worry about your tools, that you are not going to have an undercut or you are going to have some section, some issue. Here you get a design freedom. So with the design freedom, the designers were able to design a completely different block to have multiple cells assigned to it. Time was efficient, so it was done in less than 20 hours. So let's take an example. If this was done, and then if it had to go through a traditional manufacturing process, it would have taken quite some time because you have to do it, then plan your manufacturing setup. It could go with multiple setups, and then you get a component. But here you do it evening before you are going home, give it to a print command. Next day morning when you come, you have the part in hand, put it for trial. So that is what we are talking about fast. And of course, weight saving. Definitely, huge amount of weight was saved. Very important. One more example for manufacturing tooling. Now all of you can go through the figures. This is again from a OEM. So they had this fixture. Now this is quite some time back. I have worked with the OEM. So this fixtures, they were doing it from an aluminum block, 75 kg aluminum block, machine for 100 hours, and then to get a fixture, which was they were going to use it on the shop floor. So 75 kg aluminum block machining, and then the end use fixture was 2.3 kgs. What we did, we printed the fixtures. 34 hours it took us to print the fixture. We printed it. End use part was 800 grams. The cost 30,000 rupees. So you can just see we are talking about 1,50,000 to 30,000, and that's the thing we are talking about on the manufacturing side. So this is one tool. So when any automotive is launched or any vehicle is launched, you have multiple such tools. And traditionally it is done using aluminum. But do you really need aluminum? Yes, in some cases. But in most of the cases, you can think of additive manufacturing which will help you in getting a good part. Another example, again a manufacturing tool. I'm not talking about prototyping yet. This is manufacturing tool. Another example, forming tool. Now, all of us have seen that we use metal to form plastic, but here we are using plastic to form metal. That is something different. We are using ABS or we are using nylon carbon fiber plastic to form metal. And when we talk about metal, I'm talking about aluminum sheet of 1.5 mm thickness, not all metals. Please let me clarify, but aluminum sheets can be formed. Here's another example, lowering manufacturing cost, end-use parts. This is basically a sensor cover, rain sensor cover. Now, traditionally you can do it through injection molding. You do an injection mold, which is going to take some time and money, and then you are going to make a part. You can do it. But here, this rain sensor cover, 80 numbers of rain sensor covers, we were able to print in 13 hours. 1-3. In 13 hours, we print this, and then you can dispatch it wherever you want it. You are not required to carry any inventory. Do you need 80 numbers in one day? Fine. Go ahead, print it, use it if you want to do it. No carrying of inventory. That reduces your cost. Another example, customization. Now, this is something I was talking about. This was a crazy steering, basically. The customer wanted the entire interior of his car to look like marble, which is not possible. You cannot have marble inside the car. So, what was done? Everything was printed in marble texture. So we can print even in marble texture, or you can print it in jean, whatever cloth, any texture you want can be printed on. Everything is printed, fixed on that, it looks like marble inside the vehicle. Another, this is from Audi, styling, a new tail lamp is into market. How we are going to see what is required, print that tail lamp. Put it on the vehicle, use it for trials, use it for testing. You can do it. On the EV side, here's an example of an EV vehicle where it was printed so it can withstand a person's weight. Cost reduction, 50% of the prototyping cost was reduced and it was able to sustain the entire weight. Another example, innovation. Now this is again customization. So here if you see the side skirter, now this is customized. It's not the standard side skirter. The person goes there, he says, I want a different skirtle on my vehicle. What do? You cannot do it. You cannot do injection molding of one skirtle and then put it on the vehicle. Print it, put it on his vehicle and he is happy, you are happy, ready to go, you are going to get your money because that's a premium product that you are selling. That is what you can do. Customization plays a very important role in this. All these components, I have just shown you around 10 components here. Take an example that these 10 components are to be supplied all across India. So what do? Either he is going to have an inventory and then he is going to say 1000 parts to Delhi or 1000 parts to Punjab. He is going to supply it, and when it goes there, they are not going to use the 1000 parts on the same day. They are going to put it in stock and then they are going to use it over a period. But instead of that, let's say this OEM has a machine in Delhi and then they want a part to be used. They want 5 parts to be used on that day. They just tell that we are going to have the 5 parts. They print the 5 parts and use it. That's it. So you're not going to carry your inventory all across. You're not going to send your inventory from one place to another. You are going to reduce your carbon footprint. You are going to reduce your inventory cost. It is going to help you. So this is where people are now talking about additive manufacturing, which will help in supply logistics, supply chain management. So if you look at the advantages, time to market, yes, additive manufacturing helps you in reducing the time to market. Weight, definitely yes, it reduces lot of weight because you can consolidate your part. You can do a totally different design with the design freedom, absolutely no problem. Part consolidation, very high, you can use it. Production cost can be reduced definitely a lot. We have seen some of the cases where we inventory cost, we can bring down to minimum. Customization, very high. Supply chain, on demand, yes, you can do it. So this is what additive manufacturing is doing. Additive manufacturing, 3D printing is just not about prototyping. This is something what people are using and they are doing. We have got customers all across India. We got around thousands of machines. So not necessarily one technology is going to offer to everyone or for all requirements. but different technologies for different requirements. So we got a huge range of technology. So could be a range for prototyping, or could be for styling, or could be for manufacturing. Entire range of spectrum of technologies available with us.
Healthcare centric as dental dentures, right? I mean, have we reached there? I'm seeing some of the startups talking about it. So 3D printing has been there, but are we there where we talk about human body parts, also 3D printing? I heard about heart being 3D printed, but at least about dentures.
Yeah, actually, yes, I did not go into that because this being an automotive section, I did not go into medical. We do have a lot of medical organizations or hospitals, they use our technology. What you're saying, dentures, yes, can be printed out, can be put in. We got technology which we can have implants, customized implants, which can be actually used, put it into the patient. So yes, we are there, can be done. Of course, we are also currently now, when I say we, it's not we basically, additive manufacturing in the sense, is now currently developing organs using your cells. So they take the cell of the patient and then you can entirely develop an organ. It could be an ear or it could be a liver. Now that is where additive manufacturing is going on. Still a long way to go, but yes, the progress is there. Okay.
Show different materials that can be used for additive manufacturing. So we typically face a lot of problems in terms of when the vehicle goes end of life, or there are some limited issues which are like manufactured. So the spares of that becomes the major concern, and then I see a lot of potential of this technology for giving spares to our customers.
We have a technology called P3 technology where we ask the user, you develop your own material, can be used in that. So we give the freedom to the users that you all can develop, because some of the users, they want something which they develop on their own, the different material altogether which is not available. So that material also can be used on one of our technologies, and then you can put it into the market. Yes, that is available.
Super great. How about accuracy? How we can match, because if we are talking about the end use parts, then how we can able to achieve the you can say as machine part or as printed parts between. I know that strength will be as good as manufactured goods, but what about the accuracy? Because of fitment point of view, accuracy is important. So how can?
Absolutely. I was wondering who is going to ask me about accuracy. About end parts, toolings and all, they require high accuracy. So out of machine, from Stratasys machine I'm talking about, we are talking about 100 microns out of machine accuracy. We got technologies which will give you 50 microns out of machine accuracy. Okay. Now, in certain cases, we have got certain customers who need 10 microns accuracy. So what they do is, they use our technology, which could be a 50 micron accuracy they get. The same component is put up on a machine, and then just they take a one simple cut on that, which will give them the 10 micron accuracy. That is also possible. You can put this on a milling machine, on a lathe, absolutely no problem, you can do it. But out of machine, either you get 50 or 100 microns. I think that is fairly good enough for most of the components. Yeah. Okay.
Related to the last question, I think sir has asked about the medical application. Yeah. I think the technology has upgraded now that similar to the CT scan data and MRI X-ray scan data, there is a software available, we call it as DICOM to print, and that it transfers that file into the STL file, and then we can able to print the same data like for the implant manufacturing. Either it may be related to the orthopedic or related to the brain or any organ, and we can able to get it printed in metal and plastic also, I think.
Absolutely right. Absolutely right. In fact, next week I'm going to a hospital. I have the same presentation. So we are going to use the DICOM images to print the parts. Absolutely, you are right on that. Yeah? Okay, I think that's it. Thank you.